Hey, I'm Bob at ILikeToMakeStuff. Today I'm going to make some bike lights that are motion activated. This video is sponsored by Intel, and they challenged me to come up with a project to take advantage of some of the features of their brand new Arduino 101 board. This is an Arduino compatible board, but it has a real-time operating system and a 32-bit processor. The size and shape is almost identical to the Arduino Uno, but it's got extra features on it as well. On board, it's got Bluetooth Low Energy, which is really awesome, and a 6-axis gyro and accelerometer. You can get those features in other modules, but it's really nice to have it built on board for quick prototyping. So Intel asked me to come up with a project using just the board and the onboard sensors. And for a while, I'd been considering making a lighting system for a bike based on an Arduino. So in this case, I decided to use the accelerometer on board to change the brightness and color of the lights based on motion. All right, let's check it out. There wasn't really any circuitry to put together. In fact, I just had to solder a few wires. In this case, I soldered on some pins to the end of these wires and then slid them into a connector. This connector connects to the battery just so I can get power out and drive my board and my lights. Let me walk you through the electronics for this project. They're actually really simple. There's not a whole lot to put together. Most of the work on this project is actually in the code, not in the circuit. So let's walk through the electronics real quickly, then we'll look at the code. I've got the whole thing prototyped here, so let's walk through it a little bit. I've got a LiPo battery. This is an 11.1 volt. It's connected to the breadboard with a switch, so I can turn the whole thing on and off. The breadboard is just handling power. I've got power and ground coming in here. They split off into two different places. The first one goes here to this white box, which is a voltage converter. This takes the essentially 12 volts down to 5 volts is what the LEDs need. So the power for the LED is running through here. The Arduino 101 is powered through here with 11 volts. Now this board can handle 7 to 12 volts as a voltage input, which is different than some of the other boards. A lot of them only take 5. So this one is okay to take 11 volts directly from the battery. So essentially we have power with a switch going to the board, which splits off into 5 volts or into 11 or 12 volts. The LEDs themselves are actually controlled by this pin. They're just connected with one data pin and a ground. So that's the entire circuit. Basically, everything is on this board. It's just power. Before we look at the code, let me tell you what this is actually supposed to do. The idea is that the bike would have two lighting states. One, when the bike is stationary, it's gonna have a parking light on, which will be kind of an amber color. And then once the bike starts moving, it'll turn into a white light, and it'll be much brighter to make sure that everybody around you on the road can see you. There's also gonna be a small section of lights behind the seat that will be bright red, and those will kind of act as a tail light. There's not a whole lot of code to make this happen, but let's take a look at it really quickly. The code, I started out with one of the example programs that actually was installed when I installed the libraries for this board. I started with the example project called Motion Detect. Essentially, it does exactly that. It just detects motion. It has everything set up for the threshold as to what it thinks is motion, and you can modify that just by changing a couple of numbers. It does some basic setup for the callbacks, and then it just prints out all this information into the serial monitor. The loop here just checks constantly to see if it's been more than 1 second since the last motion, and then changes the LED on or off based on that motion. Every time motion is detected, it calls this event callback. And from that, you can figure out which axis the motion is happening on and which direction it's going in, whether it's positive or negative on the X, Y, or Z axis. So I started with that code and just added some LED code on top of it. I brought in the Adafruit NeoPixel library. I set up some basic information about which pin it was connected to, how many LEDs I had, and how many lights I wanted to be the brake light on the back. I added a few variables, but the biggest one was to change the timeout. Instead of 1 second without motion, I set it to 3 seconds. You can modify this line right here to change it even further. At the end of the setup, I just turned on the LEDs and then ran my blink startup function, and that just runs the lights a few times through sequence to let you know that it's started up and it's ready to go. The loop is pretty much the same, except instead of turning on and off the onboard LED, I'm just setting my strip to white. Nothing really happens here in the callback. I just left it in so that you could see it, but essentially, it just happens all up here in the loop. If motion is detected, it sets them white. If motion is not detected, it sets them back to the amber color. These functions set white and set amber are just defined down here at the bottom, and all they do is set the entire strip to a single color. I'll have this code linked down below. It'll be on my GitHub. You can get it, modify it, change it, do whatever you want to with it. So let's test it out. All you gotta do is flip it on. It does a little power up sequence to let me know that it's starting, and then it's ready. It's waiting for motion, so as soon as I move the bike in any way, it lights up. It'll stay on for about 3 seconds and then power down until there's motion again. So as long as the motion continues, they'll stay lit up white. I used a breadboard to prototype this, and that makes it really easy to plug and unplug wires while you're testing. To actually put it onto the bike, I needed it to be more permanent, so I cut a small piece of perf board and then just ran everything through the through holes and soldered them in place. And in this case, really all I'm doing is putting all the grounds into one place and all the power wires into one place and soldering them together. The only other thing connected here is a switch, just so I can cut the power to the board. I use some hot glue to hold the pins in the Arduino. It'll keep them in place, but they'll come out very easily when I'm ready. I measured the overall size of these electronics and then made a box using MakerCase. It's a website that lets you generate a template for making a finger jointed box with a laser cutter. I know not everybody has a laser cutter, and you don't need one at all. You could make a box in any way that you wanted to. In fact, you could put these electronics in a plastic bag and it would work just fine for prototyping. But in this case, I get to test out my new laser cutter and make a finger jointed box. This only took about 5 minutes to cut and the pieces fit together perfectly. This is a really quick and easy way to make an enclosure for a prototype. If you don't have a laser cutter and you're curious about them, check your local makerspace because a lot of them have them available. To assemble this box, I just used a little bit of CA glue to hold it together. I didn't use a ton of glue in case I wanted to knock it apart and change anything about it. It would come apart pretty easily. I set the battery in place and then glued in a divider just to hold the battery separate from the electronics so they didn't knock into each other too much. I dropped everything in place and then marked where I wanted the wires to pass through and the switch to be. I could have added these to the laser cutter file and actually had them cut, but I just used that template right out of that website, and so it didn't have these things. I just drilled some holes and popped these things in place. Ran the wires through, plugged in the 2 wires to the LEDs, and then turned on the power. And of course, had to put my sticker on it. It works. Since this is a prototype and I want to be able to get back into this, I just use a zip tie to hold the top onto the box. In fact, I'm going to use zip ties to attach this entire thing to the frame because I can't use my own bike. The frame on my bike is a little weird and not really good for this application, so I borrowed a more typical bike from my friend to test out with. So I'm also going to use some zip ties just to attach the lights to the frame to hold it in place so I can test it out. Obviously, how you mount this and even the length of the LED strip is going to be really dependent on the specific bike that you're working with. All right, let's put this thing on and test it out. Zip ties work great for testing, but if you want a more permanent solution, you can get some waterproof double-sided tape, or some LED strips even come with adhesive on the back already. That makes it quick and easy. And when I was putting this on, I realized that the water bottle mounts on the frame would be a great way to mount the box next time. After I got it fully mounted, I turned it on to make sure everything still worked, and it did, but it really shines at night. It feels a little bit like Tron when you're riding it. It's cool because the lights mostly face down, so they're not shining up into your eyes, but it looks pretty awesome when you're going down the street. It's surprising how much they shine down onto the street as well, so it's almost like having a headlight, even though you should probably also have that too if you're going to be riding at night. It actually worked out really well on the first try, and I think this is a really good first step to a larger project. Having those onboard sensors gives you a lot of capability that you can add just through the code. And since you can detect how far it's leaning in any direction, imagine you put LEDs on both sides of the bike and change their brightness based on how the bike is leaning. You could get some like auto turn signals. I'll have my code linked down in the description. You can go get it, add to it, change it, do whatever you want to with it. I'll also add some information about the Arduino 101 board if you're interested in checking it out as well. Thanks to Intel for sponsoring this video. It was really cool to work with that board, and I'm looking forward to doing more of it in the future. I hope you like this one. I've got lots of other electronics as well as a bunch of other types of projects that you might be interested in, so be sure to check those out, and don't forget to subscribe. That's it for this one. Thanks for watching. I'll see you next time.